about to forget. Okay, thank you. So we are going to start again here. As we say, we are going to chapter 7, one by one, section by section. So at the beginning, we have what? We have the inverse of function. You can see inverse of function. What do you mean by inverse? How we find the inverse of the function? Is all the function has an inverse or not? That's all questions that I'm going to answer today with you. So your objective here is what? Is to answer this question together. So at the beginning, we have 7.1. 7.1. In 7.1, we are going to talk about inverse of function, inverse. So what's the inverse of function? Usually, we are going to symbolize this one as a function of f of x. But when we are going to, or we have a domain here, x, and we have a range here, y, we say x from here is going to by f to be y1 or to be f of x. This is means of the function, and the inverse means that from the other side, from the range instead of the domain to range, now we are going to change the range to domain from here to here. That's why we say inverse function. So it means that we're having the inverse side, the other side. That's the idea, like an idea, but actually the detail is more than one. We will carry on more than one. It's not just finding that one and the inverse. We are going to the other side and we are going back to the other side. No. Need some conditions of that one. So before we are starting, you can see in your book is mentioned one-to-one function. What's a one-to-one function? So we need another concept, one-to-one function, one-to-one function. We need that concept because any function, if you are going to talk about f of inverse, so the function at the beginning, the first condition to have an inverse, we say f should be. I don't say maybe or may not. I say should be one-to-one. Should be, sorry, one-to-one. So the function should be one-to-one. We have two definitions for one-to-one function. The first one is geometric. What's the function? So what is one-to-one function? You heard about one-to-one function. Am I right? You didn't hear it. You heard about that one, of course. It's in the grade 9, I think. So, right? In the grade 9 in your secondary school. So that's why it's okay. You forget, you forget. You are going to review it. So we have two definitions for one-to-one function. The first is what you can say geometrically or by graph. Geometry or by graph. You can say graph. The second is algebraic. This one is not included for you, fortunately, because need more details, more concepts of mathematics that you haven't, and it's not easy for you. That's why I'm going to just talk about it, not give you example, and I'm not going to solve example on it. I'm not going to ask you about that one. Understood? So that one just for information. For example, we say if we have two different persons, x1 is not equal to x2, so it means that they are different, totally two elements different, then the function f that we have should be also different. Means that f of x1 shouldn't be to f x2. And I'm going to give you an example. If, for example, your function, example on it, I'm going to give you two examples to get the idea. Example number 1, for example, f of x is equal to x plus 1. If you put any numbers, two different numbers, any numbers from the domain, give me any example. So you know the domain of this function is R, right? You can put any value to here. So okay, give me any two different numbers. For example, 0, 1, 0 minus 1, minus 1, 1, square root of 2 pi, any different numbers that you like. The image is not, it's impossible to get the same image. Am I right? Understood? The image is not equal. For example, if I put an f of 0, I'll get 1. If I put f of 1, I'll get 2. So 0 not equal to 1, and the image f of 0 is not equal to f of 1. Why? Because here is equal to 1, which is not equal to 2. Understood what I say? But in the second example, you can see, in the second example, example number 2, if your function is different things, for example, if I have f of x is equal to x squared, In that case, if I bring two different numbers, I will get the same image. Can you imagine you are going to take an ID picture for your passport? You are going to take a picture. You and your friend is going to shop, and the photographer will take a photo, but they give you the same result, the same image. Both of you are the same. So you are not agree. But look at here. Look at this function. For example, f of 0 is equal, no, sorry, not example, 0. F of 1 equal to what? 1 square, am I right? Is equal to 1. How about f of minus 1 is equal to what? 1. Minus 1 not equal to 1, but f of minus 1 equal to f of 1. Am I right? Say 2 and minus 2, for example. You will get 2, sorry, you will get 4 and 4. Am I right? Both minus 2 and 2 are not equal, but f of minus 2 is equal to 2 is equal to 4. So in that case, this function, I can recall that function, is not one-to-one. But the other, yes, is one-to-one. Understood what I say? That's just for your information, just to like a, I don't know, like a starting the subject, okay? Just for information. Now I'm going to translate these algebraic things to the graph to get the idea. How? Look at the example 1. Look at the example number 1. For example, you know f of x is equal to example number 1. F of x, let me again blue. If we have, look at here, if we have example 1, the same example, x plus 1. So in that case, here's your picture. Am I right? Am I right? That's your picture. So I'm going to geometrically or by the graph, I'm going to tell you what's a one-to-one. I say we have, which line? We have horizontal line test. So we have HLT, horizontal line test. For what? For testing your graph is one-to-one or not. How? Just make a line horizontally. If there's one intersection, means that this function is one-to-one. If there's two or more, it's not one-to-one. How about the second example? Can you apply that one on the second example? Look at here. Here's the other example, example number 2. Again, f of x is equal to x squared. You know about the graph. It's easy for you. And you have a test. So how we test it? Here we are. So I'm going to make a line. Am I right? You can see the intersection point with the horizontal line is 2 or more. So in that case, I see this function is not one-to-one. Understood or not? Do you have any question about the one-to-one or not? So we have two types. If I want to talk about the inverse, first of all, I should talk about one-to-one. If the function is one-to-one, it's okay, you have an inverse. If the function is not one-to-one, it's not inverse. Understood? How many pictures or how many graphs and functions do we have? Many, we got many, right? For example, tell me about the sine. Y is equal to sine of x. Can you tell me is one-to-one or not? It's not one-to-one, right? Here's the graph, you can see. Am I right? And if you have a horizontal line test, we have many intersections. That's why I see that one, that one, that one, which is not one-to-one. So it means that inverse does not exist in general. Okay? Does not exist generally or in general. Why I say that? Because later I'm talking about something else. That's why I say general. So that's what. How about cosine? Same thing. You are right. So think about the other graph or the other functions that you got it before and make a line. If there's a intersection, so okay. Otherwise, yes, so on to one. Understood? Tan generally, no. But if we specific, yes. Later we will talk about this one. Okay. Question, no question, good. So now I'm going to talk about inverse. How we find or schedule or the guide for finding the inverse. You can see from here, you have such, here's the definition algebraically, I don't need it. Here's the example, think about it for you. And we talk about that functions and that functions and that function, you know. I think it's easy for you. Am I right, Jamaat? Okay. Look at here. This function, square root of x, is 1 to 1 or not? Is 1 to 1. We have just one intersection. How about that one? Yes. How about that one? No, we have to. How about that one? Again and again. Just by the graph, you know which one is the one, 1 to 1 or not. That's about this one. And we have horizontal line test. Horizontal line test, we talk about that one. Now we have an inverse of function. Here's the definition. It's the reverse of the other function. Here's the, for example, number just for you. That one I don't interested with that example. Example number 2. So directly I'm going to the example number 3 because the example number 2 just actually is not telling about anything. We have this note. I'm going to talk about that note. If you have inverse or if you have 3 functions, for example, f, g, and h, I say which one are the inverse for each other. I don't know. For example, f of x equal to something, g of x equal to something else. If the inverse, they are inverse, f circle g should be equal to I. I means that identity function. Or we can write down by just x. Understood? Or f circle h should be x. Otherwise, for example, if it's equal to x squared plus 2, so it means that h is not inverse for f. And that one, g is equal to, you can say, f of inverse. Again, later, I'm going back to that point again. When we found something, I'm going to apply this one for you, this note. Understood? So now what's my objective for here? Finding the inverse, how to find them. That example is very important because your exercise and during the exam, you will face such example like that, actually. Understood? Then later, you know how to do it. It's easy for you. Now I'm going to write the example and on the example, I'm going to give you the rules to inverse. So example is what? Example number 3 in your page. Say what? Find the inverse of 1 over 2x plus 1. F of x is equal to 1 over 2x plus 1. First of all, the first step, f of x or y, say y is equal to something like that. So I have what? I say y equal to, easy, please, just be patient, be with me. You can find the other for you by yourself, by your hands. So 1 over 2x plus 1. That's the first step. The second step, we have what? Solve for x. Listen here, you don't need to study at home. Just listen. Solve for x. What do you mean by solve for x? Find the, no, solve for x. No. Means that x should be in the left, the rest should be in the right side. X equal to something like that. Exactly. Now we solve for y, right? Now I'm going to change it. How? I say y is equal to 1 over 2 plus 1. Am I right? I'm going to multiply by 2. So I get what? 2y. Sorry. 2y equal to x plus 2. Am I right? Jamaat? Now x is equal to what? 2y minus 2. So I solved for x. Means that only x, single x. Do not forget about that word. Single x. Single x. No square root, no number, no division, no multiplication, just x. No minus 1, just x. So we solved for x now. Understood? The third rule or the third step is what? Change x to f inverse, y to x. What do you mean by that? We have x is equal to 2y minus 2. So I'm going to apply the third step. And how? Just look at it. Change that one to F inverse. And you have to change that one to X minus 2. You got it or not? We are going to change that X in this step, that X into F inverse. And each Y into X. Easy. Ready for solving the next example? Easy, right? First, let Y equal to something. The second, solve for X. The third, change the position. Change X to, just some students do like what? They change X to Y, Y to X. I didn't say that. I say change X to F inverse, change X to F inverse, and change Y to X. That's all. Now I'm going to solve the second example. And before the second example, let me check something else. Yes?
What do you call this type of questions?
Find the inverse.
Inverse?
Yes. During exam, your question is like that. Let f of x, for example, equal to 1 over 2x plus 1 or minus 1, I don't know. So it's what? Plus 1. Okay? Then, here's the question. Find inverse or find f inverse like that. And maybe I'm give you more job, more duty, and graph it. That's it. Understood? Find the inverse and graph the inverse. Graph it. So how we do it is like that. 1, 2, 3. And then you can draw these examples easy. Now I'm going to check and apply a note. Which note? I say f inverse f is equal to x, or f if circle f inverse is equal to x. So how? That was my question that I told you. I'm going to back to that point. Can you give me any idea? Do you have any idea about how? Yes, how? How we apply this note? By example, look at here. Look at the board, you can see. Our function was what? It was, I'm going to use the red to not forget about, sorry, the black to be distinguished between them. F of x, it was 1 over 2x plus 1. Am I right? And f inverse is what? It was 2x minus 2. 2x minus 2. Now I'm going to apply this one. Which one? F circle F inverse or F inverse circle F? Which one of that one? First or the second? Because I'm going to do one of them. The other is easy, the same. Yalla. Which one? Kaim and Hakim, which one we should solve first? Okay, F inverse F. So I'm going to solve F inverse F of X. How we solved that one before, if you remember that? How? How we solve the no, that one's something else. How we solve the composition function? That one's called circle. So we say F inverse, am I right? The big one, sorry. F of X. Do you remember that? Especially when we talk about domain, I remember that. So F inverse, we are going to paste the block. We are going to paste that bracket, close bracket. So I'm going to write 1 over 2x plus 1. Now we have a machine, inverse machine. The inverse machine is say what? If you give me A, if you give me anything, A, I'm going to multiply this A by 2. After that one, I'm going to subtract by 2. Am I right? So here's my A. So I'm going to multiply 2 that one minus that one. Am I right? So 2, 1 over 2x plus 1. Any question? Do you want to repeat? You want to repeat? Okay. Yes, yes. Okay. Till here, I think it's easy, if I am right. Well, okay, now we have this one, the package. If inverse say what? If inverse say, if you have any package, anything, any number, any thing that you have, any P, I'm going to do that as P as a package. If you have P, now that one, I'm going to multiply it by 2, then later minus 2, like here. If you give me X, I say 2X minus 2. If you give me B, I say 2B minus 2. If you give me anything, I say this thing, 2 things, minus 2. Am I right? So I have what? I have that thing now. I have this package. So I'm going to write down like that. Understood, dears? Yes? Okay. Question? No question. Okay. So now we are going to multiply it. 2 by 2, 1x, you are right. 2 by 2 is equal to be 1x. What else? Plus 2 minus 2. So I got what? So means that, Kaka, means that this function is the inverse of that one, or that function is the inverse of that one. So we had the note, we see in doing the note, if we have this function with the inverse, it will be x, or that function with its inverse, it will be x. That's so we check the inverse. Understood? Dears? Good. So now again, I'm going to my examples. So this is for check, this one for the rule. I'm going to my example to find example, which, forget about that one. Which example? Okay. So you have that example, which I don't like it to mention it down later. So if example, for example, we have f of x is equal to five x to power 5x minus 1 over 2. If I have something like that. So how we find the inverse, Kaka? How we find them? You know, here we forget something. Do you know? First, what was the first step? Graph. Let me write 0. Show it is 1-to-1 or not. So you know the graph of that one will be something like that. Am I right? So is 1-to-1. So is 1-to-1. Maybe during the exam I'll give you, or maybe you are going to find it. So let me check the real, write the real example for you to get more idea. If I have something like that, x to power 3 minus 1. So how we answer this example? I'm a second example, so be careful again. But one, first of all, is 1-to-1 or not? So the graph is like that. Am I right? So y is equal to x cubed minus 3. So by the horizontal line test, by horizontal line test is 1-to-1. So the second step, what shall we do? We say y should be x cubed minus 1. Am I right? We are going to change f of x to y. So I change f of x to y. Next example, step. Solve for x. How? Well done. Yes. So how we do it like that? Am I right? So well later. Exactly. So I'm going to take a cubic root. We are going to take cubic root for both sides. So I'll get what? X cubed y plus 1. So I'll get x equal to cubic root of y plus 1. What was the last step? Change x to what? And y to what? X. So I'm going to change that one as what? Equal cubic root x plus 1. I think it's easy. Need one more example with you. Any question? Do you have any question, Gaga? Easy? Good. So here we are about one-to-one function. Now, another thing is here. We have two cases. Look at it, Gaga. Example. We have two cases. F of x is equal to x squared. We talked about this function before in the beginning. This one is not one-to-one, right? Is not one-to-one. So we say has no inverse. How? How do you know it's not one-to-one? You should write, yeah. By horizontal, let's say you should write this one. You should draw your graph. Now I will give you the same example, but with a different title. The same example, look. Now this function is one-to-one or not? Is one-to-one? Yes. Why? We changed something, right? So if I'm going to graph it or sketch it, you can see here's the graph. Understood? So if you are going to use the horizontal line test, you can see is one-to-one. Am I right? So careful, that case called as restricting domain. What do you mean by restricting? Summarizing, cutting, pressing, okay? We say that in the beginning. We say sine has no inverse. Am I right? Sine, cosine has no inverse. Am I right? But you can see in your calculator, there's a sine inverse. Am I right? So why? How? Because we restrict the domain. Here's the sine example. We have the sine generally. Look. Y is equal to sine of x. Generally speaking, we say that one is not one-to-one. Kata F inverse does not exist. Am I right? Does not exist. Sorry, D and E. D and E does not exist. Now, how about the same example, but I'm going to do something else. I say that the x between pi over 2 and minus pi over 2. Can you imagine the graph? Where's pi over 2? Where's minus pi over 2 here? So I have what? So tell me, that function is one-to-one or not? Is one-to-one. So that's why in your calculator, you can find the inverse, you can find cosine inverse, even generally is not one-to-one, but they took a specific domain. They cut the domain. So this is about restricting domain. So careful when you saw some, or when in your imagination there's a graph like that, do not be patient. Maybe there's a condition, that condition will make a graph to be one-to-one. Understood? Good. Here we are again. We have two examples. So they're easy. And this subject, let me see. Any question about that? So we got something. How to find a physical example, how we show our function is one-to-one by the graph. The second, how we find the one-to-one function. After we find the one-to-one function, then how we find inverse of the function. Am I right? How we find the inverse of the function. Then later, we try to play with the function. If it's not one-to-one, how we restrict it, how we make it one-to-one function. Any question about that concepts? These three? Good. Now we have a derivative here. Actually, I don't need that one. So example 5 also canceled. But the concept of the example 6, okay, but the method is not. You can read it. You have that one, x is greater than that one. Find the value, this one, at that one. So it means that the derivative at that point. So again, I'm not going to use example number 6. Any question about the first example? So if I asked you this function, f of x is equal to square root of x when x greater than or equal to 0, and g of x, this is another type of the question, is equal to square root of x. So f and g are inverse of each other or not? Can you answer me? Okay. F of g, yes? How do you know? Yeah, exactly. So I'm going to take G circle F or F circle G. Does not make a sense. Both are equal. For this function, I will get what? F of G of X. Am I right? So then when we say is F equal to, where's the G? Square root of X. So here we say square root of X all square, which means that X. So this means that F and G, or you can say G is equal to F inverse. Understood? Good for you. So this is the first part of the class. I'm going to stop the sharing and stop the record.